Good morning, class. It's me. I miss you all. Look, I wanted us to go ahead and continue to grow and talk about our polynomials. So what I did is I set up a board with some notes. I'm going to take this camera off of me and I'm going to put it on the board for you to take some good notes. I want you to take take a moment to get a notebook, your math notebook preferably, so you can keep everything together. And we're going to talk through polynomials. I'll give you just a minute. Okay, I hope you're ready. I'm going to turn this around so that you can see what I've done. Okay, so let's talk about graphing polynomials. When you look at the behavior of a polynomial, I want you to examine the parts of the polynomial. And down here, there's an example of a polynomial. This one goes to the 4th degree. Write down your key vocabulary, first being the leading coefficient. Your leading coefficient is going to be the number in front of the highest exponent value. So in this case, if we're looking at this polynomial, -3 is going to be our leading coefficient. Okay, the negative part matters. We'll talk about that in a minute. Then degree goes to our exponent. This goes up to the 4th degree. The term refers to the number of parts in our polynomial. So in this case, we have 1, 2, 3, 4 parts in our polynomial. Okay, so let's see. Our leading coefficient, as we said, was -3. Our degree is 4. What does that mean? That means that that graph behaves in a certain way. So the rule for a graph that has a leading coefficient that's negative and a degree that is even is that the function will increase infinitely as x decreases, and the function will decrease infinitely as x increases. We'll try another one. Okay, let's keep going. Let's try another one. Okay, this one's a little bit different. Okay, let's say we have, try to get it where you can see it. Our function is 3x squared minus 3x to the 5th minus 14x minus 2x to the 3rd power plus x to the 4th power minus 5. Our first step, this is not in order. We need to put it in standard form. Standard form with our polynomials means that we go from the largest exponent down to the smallest, which would include our constant at the very end. So what I did was I rewrote my order of my original polynomial. I rearranged everything so that I had my -5x to the 5th as my first term and my -5 as my last. I want you to go ahead and rewrite that. And now once you rewrite that, we need to identify our parts again. Our leading coefficient, I just put LC for short, is -3. Our degree, which is our highest exponent, is going to be 5. Now we can determine the type of polynomial that we're working with. So our rule is going to look at an odd function. We're looking at our degree because it's an odd number, the 5. It makes it an odd function. With an odd function, then we look at our negative leading coefficient, which is -3. Odd function with a negative leading coefficient has this behavior. The function will increase infinitely as x decreases, and the function will decrease infinitely as x increases. I'm going to take a second and write that down. You're going to need all of these rules that we have. Okay, let's try another one. Okay, so for this one, f of x equals x cubed minus x plus 4x to the 4th plus 7x to the 5th plus 3. First thing I want you to do is rewrite it in our standard form. Okay, I already wrote it down. I rearranged them, so now 7x to the 5th is my leading term in my polynomial, and those parts are critical for us knowing what the behavior of the polynomial is. So my leading coefficient is 7. My degree is 5. My degree determines what type of function it is. Whenever we're using the word function, think y. Whenever you say function, think y. So it's an odd function, because 5 is odd, with a positive leading coefficient of 7. So, and I wrote this in shorthand. You'll see this in some of your problems on Pearson. They'll have it this way. It's saying the exact same thing. It's really saying when my function is approaching negative infinity, then my x is decreasing. Okay? Or you can just say as x decreases, my function decreases. As x increases to positive infinity, my y increases to positive infinity. Okay, hopefully this will help you all today, and I'll post another video. Anyway, I miss all of you all, and you can certainly email me if you want to at agy6800@gmail.com. Talk to you later.